Chemical bond is one of the important concept, and different types of chemical bondings are there, and ionic bond, covalent bond, coordinate covalent bond, and in addition to these things metallic bond is there and hydrogen bonding is also there. And out of all these things, covalent bond is especially very important for all competitive exams, and in this class we are going to learn few things related to covalent bond. Let us start that one. Let us check first one. A covalent bond is likely to be formed between two elements which, option A, have high electronegativities, option B, have low ionization energies, option C, have low melting points, option D, form ions with a small charge. We know that covalent bond is formed due to sharing of electrons. The sharing of electrons takes place between the elements which has a difference in their electronegativity less than 1.7. If they have difference less than 1.7, they shares electrons and they forms covalent bond. Now, once you check the options, option A is correct answer. We will check the second one. In nitrogen molecule, the atoms are bonded by the bonds. Option A, 1 sigma 2 pi, option B 1 sigma 1 pi, option C 2 sigma 1 pi, option D 3 sigma 2 pi. What is nitrogen molecule? Nitrogen molecule has triple bond. Nitrogen molecule has a triple bond, and see here, out of 3 bonds, one is a sigma bond and remaining 2 are pi bonds. Whenever there are 3 bonds, one is a sigma and 2 are pi bonds. When there are 2 bonds, one is a sigma and one is pi bond. When there is only one bond, that is sigma bond. And see here, I will explain how this triple bond is formed here. For our competitive exams, this point is enough, but for better understanding, I will explain the structure, how it is formed. Okay. Let us check the number of unpaired electrons in nitrogen. And we know that only unpaired electrons participates in bond formation. See here, nitrogen atomic number 7, 1s2, 2s2, 2p3. See here, the valence shell has the configuration. See here, there are 3 unpaired electrons. We have to write according to Hund's rule. There are 3 unpaired electrons, and see here, each unpaired electron is present in each p orbital. Now see here, I will write one more nitrogen, and see here, one more nitrogen also same configuration, and I will draw directly, and see here, and see here, now bond will develop. Direct overlapping leads to sigma bond formation, and side by side overlapping forms pi bond. There are 2 pi bonds and 1 sigma bond, and as a result we can see triple bond between 2 nitrogen atoms. In a nitrogen molecule we have triple bond, and one is a sigma bond and remaining 2 are pi bonds. Option A, 1 sigma and 2 pi bonds is right answer. Now we will calculate third one. Anhydrous aluminum chloride is covalent while aluminum fluoride is ionic. This is justified by option A, crystal structure, option B, valence bond theory, option C, Fossen's rule, option D, lattice energy. In the given question, they gave one information. Aluminum chloride is covalent. Aluminum fluoride is ionic. They are asking which of the following explains this one. And we already learned Fossen's rules. Fossen's rules are very important to explain the ionic and covalent nature of the molecules. And see here, aluminum is the common central atom. Aluminum is common. And see here, what are the side atoms here? Fluorine and chlorine. Fluorine and chlorine are side atoms. And see here, fluorine and chlorine belongs to same group, that is halogen group, 7th year group. And according to Fossen's rules, if the size of the anion increases, what will happen? The covalent nature will increase. Here, the size of fluorine is small, that's why it favors ionic bond, whereas the size of chlorine is large, hence due to large anion size, it favors covalent bond formation. Okay, now check the options. Option C, Fossen's rule is right answer. Fourth one is interesting one. Let us check the fourth one. The compound which contains both ionic and covalent bond is option A, CH4, option B, C2H2, option C, KCN, option D, KCl. Now we will check what are the different types of bonds present in these four molecules. And see here, in case of CH4, what is CH4? CH4 is nothing but methane molecule. It has 4 covalent bonds. It has 4 covalent bonds. And next one, it is acetylene molecule. Here carbon-carbon triple bond is present and it has single covalent bond with hydrogens. All are covalent bonds. Here all are covalent bonds and here also all are covalent bonds. But our question is which one has covalent and ionic bond? Let us check third one. Option C, here they given KCN, and we know that cyanide ion is nothing but C triple bond N with negative charge. And see here, the cyanide ion develops ionic bond with potassium ion. This is a potassium cyanide which has both a covalent bond and ionic bond. And our question is based on covalent and ionic bond. Our answer is KCl, no doubt in it. Let us check KCl also. And see here, in case of KCl, K plus Cl minus, it has only ionic bond. There is no covalent bond. Once again check it. Covalent bond, ionic bond and covalent bond, and only ionic bond. And our answer is KCl, which has both covalent and ionic bond. Please note down this. Fifth question is on covalency. Let us check it. The covalency of nitrogen in HNO2 is option A 0, option B 2, option C 3, option D 5. Before discussing the answer, first we have to know what is covalency. Covalency is nothing but the number of electrons shared to attain octet configuration. And we know that the number of valence electrons in case of nitrogen 5. And here in case of HNO2 molecule, we have 3 side atoms, 1 hydrogen and 3 oxygens. And see here, already it has 5 valence electrons and it shares with 3 side atoms. As a result, it will attain octet configuration. And what is the covalency here? It is sharing with 3 side atoms, 1 electron each. And that's why the covalency of nitrogen in HNO2 is 3. Option C is right answer. Let us check sixth one. Perfect covalent bond is present in option A, AgCl, option B, HCl, option C, Cl2, option D, CO. They are asking which of the following has a perfect covalent bond. See here, very simple to answer this one. Perfect covalent bond in the sense they should have the difference in electronegativity as 0. See here, in case of AgCl, they have 2 different types of electronegativities. That's why electronegativity difference in electronegativity is not equal to 0. And here also same thing. Electronegativity difference is not equal to 0. And here it is formed between 2 identical atoms. Means we have to subtract the same value from the same value. That's why the difference in electronegativity is equal to 0. And in case of carbon and oxygen, the difference in electronegativity is not equal to 0. Okay, if the difference in electronegativity is 0, then it forms perfect covalent bond. Option C is correct answer. Fossen's rule is one of the important one, and there is a question on Fossen's rule. And please note down the seventh one. As per Fossen's rules, incorrect order of covalent nature. Before checking the options, first we have to recall Fossen's rules. See here, large cation, small cation. Large anion, small anion. See here, according to Fossen's rules, large cation and small anion favors ionic bond formation. Small cation and large anion results in the formation of covalent bond. Large cation, small anion, ionic bond. Small cation, large anion, covalent bond. Now, keeping those things in mind, we will check the options. Okay? And see here, in case of first option, sodium chloride, magnesium chloride, aluminum chloride is silicon chloride. In all these things, chlorine is common. That's why leave that anion. Now we have to focus on cation. See here, sodium, magnesium, aluminum, silicon. From left to right, the cation size is decreasing. Cation size is decreasing. Small cation favors covalent bond formation. This is covalent in nature. This is covalent. Next option B. Lithium fluoride, lithium chloride, lithium bromide, lithium iodide. Lithium, the cation is common here. Leave that cation, focus on anion. See here, fluorine, chlorine, bromine, iodine. In case of this one, from left to right, what is happening? The anion size is increasing. Large anion favors in covalent bond formation. That's why this is also covalent in nature. Next, check third one, aluminum chloride, aluminum oxide, aluminum nitride. In case of these things, aluminum is common, leave that cation. Now, check this one, chlorine, oxygen, nitrogen. In case of this one, chloride ion, oxide ion, nitride ion. What is happening here? Here, from left to right, means chloride to nitride, the size of anion is increasing. Large anion results in covalent bond. And see here, option D, lithium chloride, sodium chloride, potassium chloride, rubidium chloride. Chlorine is common, leave that anion. Now, focus on cation, lithium, sodium, potassium, rubidium. What is happening here? From left to right, cation size is increasing. Large cation with anion results in ionic bond formation. This is ionic in nature. They are asking which one is incorrect with respect to covalent nature. First three are covalent, then incorrect with respect to covalent in the sense option D is correct answer, because option D is ionic. It is showing the increasing order of ionic nature. Let us check the eighth one. Here they are asking what are the different types of bonds present in a molecule. Okay, please note down this one. Types of bonds present in ammonium chloride molecule. Option A, covalent. Option B, ionic. Option C, coordinate covalent bond. Option D, all the three. Ammonium chloride is one of the important compound in our chemistry. See here, we already studied in our lower classes, ammonium chloride is white salt which undergoes sublimation process, that one, this one, okay. And see here, now we are going to check the different types of bonds in it. Now see here, nitrogen has 5 valence electrons. Here 3 hydrogens they develop covalent bond. Then as a result we will get ammonia molecule NH3. This NH3 has a pair of lone pair of electrons. Now H plus ion will approach. H plus ion has no electrons. It will approach. Then what will happen? Here nitrogen contributes the 2 electrons. See here, if one of the bonded atom contributes a complete bond pair, then what will happen? A coordinate covalent bond will form. Coordinate covalent bond is also called dative bond. Now we have NH4 plus. First we have NH3. After that, now we have NH4 plus. Now chlorine with negative charge, chloride ion will approach. As a result, between NH4 plus and Cl minus, ionic bond will form. See here, as a result of the electrostatic force of attraction between H plus and Cl minus, means oppositely charged ions, electrovalent bond, ionic bond is formed. As a result, here we will get NH4Cl. Finally, what we have? First we have covalent bond and then dative bond. What is dative bond? Dative bond is nothing but coordinate covalent bond, and then ionic bond. What is our option? They gave covalent bond, ionic bond, coordinate covalent bond, all the three. Answer is all the three, because it has covalent bond, dative bond and ionic bond. Okay, let us check that one. Option 4 is correct answer. Option D is right answer. Please share our videos with your friends and discuss with your friends regarding Mr. Chemistry. Mr. Chemistry is one of the best channel for chemistry to understand JEE and NEET tricks and tips. Okay, please subscribe to our channel Mr. Chemistry. Thank you all of you.